Okay, class, we've made it to the last lesson of Chapter 5, Chapter 5.9b, using the sine, cosine, and tangent. What we're going to do is use those trig ratios in order to find the lengths of missing sides. This allows us to know the angles of a triangle and one side of a triangle, and then be able to find all the other sides. In our first example here, you'll notice that if we take the 30-degree angle, n is the opposite, and we know that this is the hypotenuse. And the sine is found by taking the opposite over the hypotenuse. Remember, we're still working with SOHCAHTOA. So I set up an equation that tells me that the sine of the 30-degree angle is going to be the length that I do not know, which is n, over the length of the hypotenuse, which is 14. Now, I have an equation here. We're used to seeing it this way. Right? But it's still an equation. We are going to multiply both sides by 14. Now, normally, we're used to just putting the 14 here and then putting the 14 here. We kind of take a shortcut and we say, look, this 14 and this 14 would cancel. So I'm going to have n equals 14 times, and then I switch my parentheses to be the sine of the 30-degree angle. Now, I can substitute for the sine of the 30-degree angle. If I use my calculator and find the sine of the 30-degree angle, it will be 0.5. So n is going to equal 7 meters. Now that's the long route. Okay, that's the background for what we're doing here. Now, you got to remember, on your XA calculators, you're going to take 14 times 30, then sine, then equals. If you have the Roman numeral 2s, you are going to take 14, hit times, hit the sine button, then hit 30, then press equals, and you should come out with 0.5. Well, actually, you should come out with the exact answer of 7. So sometimes we don't really substitute it, we just roll it through a calculator. Whoops. Skipped example A here. All right, we're going to round to the nearest tenth. We know that we're going to have this angle. Here is our opposite, and because this is the right angle here, this has to be the hypotenuse. That tells me that the sine of the 55-degree angle has to equal the n I do not know over the 20 I do know. Multiplying both sides by n, I'm going to take 20 times the sine of 55 degrees. That's going to equal n. Now, notice I got from my step 1 to my step 2 without showing to multiply both sides. The book at this point figures that you know what you're doing to solve n over 20 equals a sine of 55. Now, this is where I can roll it through my calculator and round off. Remember, 20 times either 55 sine equals or 20 times sine 55 equals, and you should come out with 16.4 feet when you round to the nearest tenth. The cosine is going to be pretty similar, although remember, cosine, it's SOHCAH, so we need adjacent and we need hypotenuse. In A, we can clearly see that we have an adjacent side and we have a hypotenuse to our 40-degree angle. So I'm going to use the cosine of 40 degrees. Yes, you really should put in the degree sign. And that's going to equal n over the hypotenuse of 9.5. Multiplying both sides by 9.5, I'm going to get 9.5 times the cosine of 40 degrees equals n. Putting it through the calculator, you should end up with 7.3 centimeters. At this point, you should hit pause and try example B. Now the tricky thing here is you got to remember though that this is an equilateral right triangle, so we're going to be working with that particular side. We need to find the hypotenuse, so it's a little bit different. So the cosine of the 45-degree angle is going to be 8 over the hypotenuse. Now here we would multiply h by both sides. Remember back to that isolating the variable lesson that we had in chapter 4. So we're going to have h times the cosine of 45 degrees. That's going to equal 8. Now, I'm going to divide both sides by the cosine of 45 degrees because I want to get h by itself. So h is going to equal 8 divided by the cosine of 45 degrees. And yes, I can put that into my calculator. If I have a 30xa, I'm going to put it in as 8 divided by 45, then hit cosine, then hit equals. If I have the 30x Roman numeral 2s, I'm going to press 8 divided by cosine 45 and equals, and I should come out to 11.3. So h is going to equal 11.3 centimeters. Then we're going to move on to tangent. Now remember that tangent is the TOA. That's the opposite over the adjacent. And in this case, I don't know the opposite to the 60-degree angle. So the tangent of the 60-degree angle is going to equal n over 275. Multiplying, I will get 275 times the tangent of 60 degrees equals n. And when I push that through my calculator, I should get 476.3 meters. In my last example, you're going to find out that it's probably a good idea to try to draw a picture or a diagram. We have a ladder resting against a house that forms a 75-degree angle with the ground. Okay, so here's our house. And there's the ground. The angle with the ground is going to be 75 degrees. We need to find, and we know that it's 8 feet away to the base of the ladder. They want us to find this measurement right here. How far is it from the top of the ladder to the base of the house? So I'm going to use the tangent of 75 degrees is going to equal the opposite, which is n, over the adjacent, which is 8. Multiplying both sides, I will take 8 times the tangent of 75 degrees equals n. Should really put that in parentheses, I guess. So n is going to equal or be approximately 29.9 feet. And that concludes our final lesson for Chapter 5. So Scout and out.